First-order logic, FOL, serves as the backbone of knowledge representation in artificial intelligence, providing a formal language to express complex relationships, rules, and constraints within a domain. Its expressive power enables AI systems to capture the intricacies of real-world phenomena and reason logically about them. By employing symbols such as predicates, variables, quantifiers, and logical connectives, FOL facilitates the encoding of knowledge in a structured and interpretable manner. This structured representation forms the basis for automated reasoning, inference, and decision-making in AI systems, enabling them to solve problems, answer queries, and make informed decisions across diverse domains. From expert systems and automated planning to natural language understanding and semantic web technologies, FOL finds wide-ranging applications in AI, underpinning the development of intelligent systems capable of understanding, learning, and reasoning about the world. Here are some applications of first-order logic in short lines. 1. Expert systems, utilized for knowledge representation and reasoning in expert systems. 2. Natural language processing, employed for semantic parsing and understanding in NLP tasks. 3. Automated planning, used for representing states, actions, and goals in planning systems. 4. Semantic web, facilitates knowledge representation and reasoning on the web. 5. Database querying, provides a formalism for expressing complex queries in databases. 6. Cognitive modeling, enables modeling of human-like reasoning and inference in cognitive systems. 7. Robotics, utilized for representing and reasoning about the environment and actions in robotics.